Morning calculus class today. Today we'll talk about the area between two curves. So this one is for section 6.1. Okay, so we'll take a look at that. So the area between two curves. So let's say that we have an upper curve, lower curve, f of x versus g of x. So once you need to find the area right between those two curves, so we need to find out the boundary. So from A to B. So f of x minus g of x, because it's an upper curve minus the lower curve, so we can get the difference. And once we integrate it, so you get the area bounded right between those two curves. So this one is the vertical approach. So what about the horizontal approach? So for the horizontal approach, so basically it's similar, but we need to flip that x and y over. So we need to convert that x in terms of y. So f of y, then that'll be considered the right end of the curve. And then g of y, that'll be considered the low end of the curve, the left end of the curve. And then the boundary right between those two, so those are the y value from C to D. So integral from C to D, f of y minus g of y, integrating it with respect to y. So it's a horizontal approach. So now, we'll take a look at that, some of the example here, so and see which one that we're going to use. So sketch the region enclosed by the given curves. Decide whether to integrate with respect to x or y, then find the area of the region. Okay, so the first thing that you want to do, you want to sketch the graph first. Okay, so for the first one, we do have y equals x squared minus 2x, and then y equals x plus 4. So sketch the graph. So we do know that the first one is a quadratic, so we can complete the square for this one first. So x squared minus 2x, so negative b over 2a, so add 1, and then subtract 1. And then try to factor the trinomial. We do have x minus 1, quantity squared, minus 1. So 1, negative 1, and that would be the vertex. Okay, so sketch the graph first. And then the other one is just the line, so 1, 2, 3, 4 for the y-intercept. And then the slope is 1, up 1, 1 over to the right. Keep going that, so that would be up 1, 1 over to the right continuously. So connect the dots. Okay, so like that. Now, you probably want to find out the point where they intersect right here. So the way to find out the point where they intersect, you can just set that equation equal to each other. So x squared minus 2x, so that equals x plus 4. Bring everything all together to one side, so we got x squared minus 3x minus 4. Set equal to 0, so we do have x minus 4 times the quantity of x plus 1. So we got x equals negative 1, x equals 4. So this one just shows the boundary, so the value of a, the value of b. It's always from the lower bound to the upper bound. Okay? The value of a, and then over here, the value of b. So now let's just set it up. So it looks like this one we're using the vertical approach. So for f of y, for f of x, excuse me, which is the line right here, so it's x plus 4. Subtract the quantity of x squared minus 2x dx, and then the boundary, it's from a to b, so from negative 1 to 4. Okay, so that's the setup. And then the rest of this, so basically using f of tc part 2. So before you integrate it, make sure that you need to combine the like term first. So we do have negative x squared, x minus negative 2x plus 3x. And then 4, just leave it. Integral from negative 1 to 4 of this whole integrand, dx. So basically the rest of this, just integrate it. So negative x to the power of 3 over 3 plus 3x squared over 2 plus 4x. Integrals, so plug in the number, the boundary, negative 1 to 4. And then the rest of this is just using that f of b minus f of a. So you guys can finish this one on your own. And now for the rest of this, so now what about for part B? So part B is quite similar. So we'll take a look at that. So one thing you guys need to watch out here is about the setup, the approach that you're applying for this, whether that's considered vertical or horizontal. And sometimes the boundary is given, then that'll be easy. If the boundary is not given, like this type of problem, so you need to find a boundary first. So what we got here, so for B, we do have 4x plus y squared equals 12, x equals y. So first thing that you want to do, you want to solve for y in terms of x because you want to sketch the graph. So solve for y in terms of x. We do have y squared. So that equals negative 4x plus 12. And then take the square root both sides. So we do have square root of negative 4x plus 12. So y equals, we can take out the negative 4 if you want to. So negative 4 and then x minus 3. So the negative, it just shows that it's a double reflection. And for those who might be wondering, is that going to be imaginary number? No, it's not going to be imaginary number. It's just a reflection. Okay, so what we got here, so for 4 we can put it out. So that would be 2 times the square root of negative times the quantity of x minus 3. Okay, so now let's just sketch the graph first. So for the vertex here, we do have 3, 0. 1, 2, 3, 0. And it's supposed to be going this way, but the thing is that due to the reflections, so we do have a reflection over the y-axis. So that means the graph is going back to the left. Okay, like this. And then the other part of the function we have right here is y equals x. So y equals x would be this one. So up 1 over to the right. Okay, so it's going to be like this. So basically what we need to find out is the area right between the curve. Okay, so as you can see that this one we need to use this sideway, the horizontal approach. So basically for this one we need to solve for x in terms of y. Okay, so how do you solve for x in terms of y? So 4x, so that equals 12 minus y squared. And then x equals 12 minus y squared over 4. You try to reduce it, so this one would be 3 minus 1/4 y squared. So for the right end of the curve, so it looks like the right end of the curve would be the radical. So we're using this one as the right end of the curve. And then the left end of the curve would be the line right here. But we still need to find out the boundary. So the way to find the boundary, so we set 3 minus 1/4 y squared equals y. And then from there we solve for y. Okay? So this one is one of the complicated process. Okay? So solve for y, or another way that we can solve for this, we can just plug in that y for x right here, because x equals y. So that might be a little bit easier. Okay, let's try to do it that way. So 4y plus y squared equals 12. Well, I just multiply by 4 both sides, so eventually you'll end up with the exact same thing. Okay, so solve for y, so we do have y squared plus 4y minus 12, so that equals 0. So y plus 6, and then y minus 2, because we want to factor it, so we got y equals 2, and then y equals negative 6. So the boundary here, it's actually from negative 6 all the way to 2. Okay, so the boundary for the curve, so it's all the way from negative 6. So try to extend the line here. So all the way up to 2, right? Okay, so basically we need to find out the area right between the curve from here and also the other part, which is down here on the bottom. So integrate it, so negative 6 all the way to 2. So the right and the curve, so we do have quantity of 3 minus 1/4 y squared. And up to that, subtract this one right here, y, and then dy. Again, the most important part of doing this is just a setup. The rest of this, you guys can integrate it. So just going back to the previous chapter, f of tc part 2. So combine the like term if that's possible, and then integrate it with the power rule. Okay, so now what about for part C? So part C, that one's a little bit different with the absolute value. Okay, so now we'll look at this. Y equals the absolute value of x. And then y equals x squared minus 2. So absolute value of x, you may notice that it's a V-shaped curve, like this. And then x squared minus 2, so down 2, with the horizontal, with the vertical translation. And then it's a parabola, so it's going this way, going that way. So one thing that we notice, this one, it's an even function. So they're both considered even functions, so that means we can just integrate part of the graph and then multiply the other part by, just simply multiply by 2. But we still need to find the boundary, so the way to find the boundary for this, so this part is what? X. This part right here is negative x. So we set x equals x squared minus 2, because we want to find the boundary of the lower bound, upper bound right here. Okay, so what we got here, so x squared minus x minus 2 set equal to 0. And it looks like this one, it's factorable, so it's x minus 2, and then x plus 1. So we got x equals 2, and then x equals negative 1. Okay, so for the value of x. But the thing is that negative 1 is somewhere over here, so since this one is even functions, so we're just choosing that 2 right here. Okay, so we're choosing 2, because this one is going from 2, negative 2 to positive 2. Okay, so now, and for those you might be wondering, how do we set up the integral? So the way to set up the integral is just like going from 0 to 2, because the other part is symmetrical, so we just multiply that by 2. And then this one, upper curve, obviously it's the absolute value one, so which is x, minus the lower curve, the quadratic, minus the quantity of x squared minus 2, and then the whole quantity times dx. Again, the setup. So the rest of this, you can integrate it, so which is what? X squared over 2, minus x to the power 3 over 3, negative, negative, positive, plus 2x, integral from 0 to 2. Let's say that you plug in 0, everything turns out to be 0, so you only have to plug in 2. But don't forget, the outside of quantity here, we do have a 2. So eventually it's going to be 2 times, so 2 squared over 2, which is 2. 2 to the power of 3 over 3, so it's 8 over 3, minus a third, and then plus 4. So we got 6 minus a third times 2. So 2 plus 4, 6 minus a third. So we got 18 over 3 minus a over 3. So it's 10 over 3 times 2, so it's 20 over 3. And that would be the area of this whole thing. So half of it would be 10/3. Okay, so now let's see what else that we have for the other part of the whiteboard here. So we just find the area run between two curves, the one with respect to dx, and the other one with respect to dy. Okay, so now let's look at this one. So the area between two undetermined curves. So undetermined curve, sometimes that means, g of x could be considered upper curve, or g of x could be considered lower curve from a certain value here. So the way to set it up, it's about the area from the integral from a to b, that's absolute value of f of x minus g of x. Because we don't know which one is going to be the upper curve, lower curve at the certain positions. So we just want to put it in absolute value. It guarantees that eventually it's going to be positive. Integrating it with respect to dx. What about for dy? dy is quite similar. So let's say you do have a sideways curve, and you're not quite sure which one is lower, which one is the right-handed, or which one is the left-handed. So basically it's quite similar. So it's from c to d, and then absolute value of f of y minus g of y, and then absolute value of dy. So again, if we do have a sideways curve, kind of like this, and then, well, this one, let's say it's f of y, and then for g of y, okay, kind of like a DNA curve. So for g of y, so basically we're just finding the area by using the sideways approach, which is by dy. And this one is by dx. Okay, so now let's take a look at the example here. So find the area of the region bounded by the curves for the following functions. So the first thing that I want to do, always sketch the graph. So sine of x, we do know that it's a roller coaster. Like that. But this one is being cut off from 0 to pi over 2. And then the other one, it's cosine of x, which is a bell curve. Okay, so bell curve. So it's going this way. Okay, making sure that's the same amplitude. So that means we're looking for the area right here and the area right between those two curves right there. Okay? So now let's just set up the integral. So from 0 to pi over 2. And the nice thing about this, the lower bound, the upper bound, they're all given. And then it's absolute value of sine of x minus cosine of x, and then dx. Okay. And now for those who might be wondering, how do we evaluate this? How do we find the exact value for the area? So one thing that we notice, so from 0 to half of the distance between 0 and pi over 2, which is pi over 4. Well, this one just by looking at the graph, or you can just set that sine of x equals cosine of x. And we just solve for x, so that means x would be pi over 4. Because sine of pi over 4 is the same as the ratios of cosine of pi over 4. So that means we need to break it apart. So from 0 to pi over 4, upper curve for this one would be considered cosine of x. So cosine of x minus sine of x. And then plus pi over 4 to pi over 2. And then for this region right here, so sine of x will be considered the upper curve. So sine of x minus cosine of x. And then times dx. And then the rest of this, all you have to do, just integrate it. And then f of tc, part 2. Okay, so now let's see what else that we have for the rest of this. So we do have one more example to go, but I just want to check one thing real quick. Okay, it looks good so far. Okay, so for part B, we do have sine of x, cosine of 2x. Looks like we have to apply the double angle identity. But the thing is that we're just making a graph, so there's no need to use any identity at all. So first thing that you want to do, sketch the graph. So for sine of x, once again, that one is a roller coaster. And the boundary is from 0 to pi over 2 once again. Now, what about for cosine of 2x? Got to be careful with this. We do know that's a bell curve, but it's going to be a new period. So the new period for this one, so the way to find the period for cosine is 2 pi over b, so it's 2 pi over 2, which is pi. So that means for that bell curve, it's only half of a cycle compared to the parent graph. So that means this one, we need to cut it off into half. So for the bell curve, it stopped here at pi over 4. Okay, so it's going this way. So decline. And this one, it just going through the curve like that. Okay, because that's only pi for the whole period. So that means we need to find out the area right between those two curves. When it's right here, and the rest of this. Okay, so once again, the general form, the way to set it up, it's absolute value, integral from 0 to pi over 2, absolute value of sine of x minus cosine of 2x. Okay, but now you want to break it apart. So half of the distance between 0 and pi over 4, then that would be pi over 8. Okay, so from 0 to pi over 8. So as you can see that the upper curve right there, that would be cosine of 2x. So cosine of 2x minus sine of x. Again, upper curve minus the lower curve. And then plus, because we need to connect with the other area together. So now from pi over 8 to pi over 2. So the upper curve, it turns out to be sine of x. Well, because